Hi students, good morning. I am Professor Ishwaraj B. Patil. I am working as a assistant professor at CSA department. Today I am going to take the lab, which will be going to do the express the Verilog code for the K-map for 4 variables. We'll see one by one, step by step. The second experiment is what? Give for a given 4 variables logic expression, simplify using the appropriate techniques and simulate the using the basic gates. We'll see how to solve this one. First I'll be taking the 4 variables game expression here. Let me how to solve it with my writings. K map. Okay, if I have the more than 3 variables, then I'll go for the K map. Means what? A Boolean expression having the more than 3 variables, then how could I can't solve this, simplify with the Boolean postulates and theorems. Instead of going the Boolean postulates and theorems, I'll be go for the K map. K map is the one of the technique to solve the and simplify the Boolean expression with the help of some K-map rules. Okay, K-map rules. There we are using the some postulates and theorems. Instead of using postulates and theorem, we will be using here what K-map rules. K-map techniques, it has the if its own rules. Okay, we'll solve how to solve this Boolean expression using the some K-map techniques. Here I'll be considering the 4 variables K-map, 4 variables Boolean expression. Okay, how to solve it? Let's see. Here I am writing the Boolean expression having the A, B, C, D as the 4 variables with the summation form. Okay, SOP form and POS form. SOP means what? Sum of products. Okay, having the mean terms as 0, 1, 2, 5, 7. Okay, then 8, 9, 10, 13 and 15. These are the mean terms he has given to simplify the Boolean expression using the K-map. Okay, I have the 4 variables here, 4 variables. That's what my K-map should consist of how many cells? 2 to the power of 4 is nothing but the 16 cells of K-map I have to design here. So that 16 cells of K-map I will be designing. Okay, let me design the 4 variables. And this is 16 cells K-map here. How to write it? Okay, I'm writing the K-map for the 16 cell K-map. Okay, okay, this is what a 16 cell K-map here. A and B as the on the row side, C and D as the on the column side I'm taking. Okay, okay, next I'll be taking the some Greek code I'm writing. Okay, I can write this with the 0 0 0 1 1 1 1 0. Okay, 1 1. I can write 1 0, but here I have to change the only one variables going to be change its state from 0 to 1, 1 to 1 as it is. 1 1 is there, 1 to 1, 1 0. Means what K-map is telling that there is a rule for that only one variable has to change. Two variables can't change at the same time. Okay, only one variable has to change from the one cell to another cell. This from its state. Okay, from its 0 to 1, 1 to 0, complement to uncomplement, uncomplement to complement. Okay, there are 16 cells. Okay, that's what I'll be having the 4 cells. 4 to 4 is 16 cells of K-map. I have the 4 rows and 4 columns here, and also similarly I can also write to the row side as the 0 0 0 1 1 1 1 0. Okay, instead of writing this with the like this, I can write as a bar, B bar, and also A bar, B, and A B and A B bar. Similarly, I can also write it what here also C bar, D bar, C bar, D, and the C D, and also C D bar. Okay, I have to index the cells. I have to give the indexing to the cells as the indexing of cells, it starts with the 0 because the 0 0 0 0 0 0 0 1 0 1 is what 1, 0 0 1 1 is what 3, 0 0 1 0 is what? 2. That's nothing but here the row and column I'm multiplying, row and column I'm multiplying. Okay, that's what I'll be making. Is what the thumbnail as the 0 1 2 3 4 5 6 7 and also 8 9 10 11 and 12 13 14 15. Means what I am doing the 0 1 or 3 2 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Means what I am doing the indexing the cells with the indexing cells with the water with the keeping the mind in the third row and third column and third row. Okay, that's nothing but the we can say it's what the indexing of the cells. Next we will put the all the numbers which are given as the mean terms here in the cells which are having this one. 0 cell is there, then I'll put the 0th cell as what? 1. These to be cells. Okay, whatever the has given mentioned the these as the what index of that particular cell. These cells has the fill up with what? 1, because it's the mean terms. In the max terms they will be putting in the POS form 0, but the mean terms SOP form, that's nothing but the SOP means what? Sum of product form, sum of products. So I'll be putting the 1 here, and so what next 2 is also 1 is here. 5 is 1 here, 5 is 1 here, and 7 is 1 here, and 8 9 8 is the 1 and 1 is 9 is also 1, put the 1, and 10 and 13, 10 is what? 1, and 13 is 1, and also 15 is 1. Okay, remaining cells fill the 0. Okay, 0 default as 0 because it's a SOP form. Okay, if any cells is not mentioned in the mean terms, that those cells will fill with what? 0. Other cells are having the mean terms, those can be filled with what? 1. Okay, that's what next step is what? Next pairing. Okay, how to make the grouping. Okay, grouping first we'll see for the this is the 16 cells. There's first 16 cells of combination pair is the grouping is possible, we'll check. Next 8 cells in the octal is possible or not, check. Then the fourth, then quadrant is possible or check. Then pair is possible or check. Then we'll go for the next. Means here the grouping can be done with the horizontally, or else we can go with the vertically. Only the vertically, we can't make the group with the with diagonally. We can't make the diagonal groupings, but here the grouping can be done with the either of the horizontal or vertical. Okay, here it is possible to have the grouping of the 4 cells having the this 4 cells as the adjacent to each other. This one considered as the quadrant. Okay, quadrant, and also these 2 cells are adjacent to and these 2 cells are adjacent, because the we will make the some grouping technique with the help of what? Folding technique. If you fold this one, we'll have the these 4 cells are adjacent to each other. Then we left with what? These 2 cells. Then also we'll go for the corner cells as the quadrant here, corner cell as the quadrant here. This means what? 4 cells of the quadrant which are having the corner cells can become what? A quadrant group, quad group. Then start the simplifying with the grouping techniques. As the first we'll consider the first group, that's nothing but the quadrant group. We will be having the first we have to check the row side, which is the common here. 1 is common, 1 can, that's nothing but the B is common here, which is term is not going to change its state, that one is to be considered common term, which is changing its state. A is changing its state from the second row to third row, A to A bar, then don't consider this one. Just to consider, just to take the common term, which is common. A B is common, B is say B. Okay, next we will check the columns. Okay, this group belongs to second column, third column. Here the common term is what? 1 is what? D here. D is taken to be consideration for the simplification. Next group is what here? This group. Okay, means what? A folding group. We can make it this group belongs to these two rows, first row and fourth row. So first row, so fourth row. First row you will consider 0 is there, then 0 is also there. That's nothing but the B bar, B bar is there. Just to take the B bar as the on the row side. Then we'll see the column side. First column, second column. Which one is common here? Which one is common here? C bar is common. C bar, that's nothing, 0 0. C bar is common. Just to write B bar, C bar, B bar, C bar. Then next we'll go for the corner cells. Corner cells having the becomes what grouping, quad group, that becomes what these are also becomes another group. So these 4 corner cells belongs to first row and fourth row. There is a common between the first row and common the fourth row is what? B bar. A is keeping change its state from A to A bar. You don't consider, just to consider the B bar as the common thing here. B bar as the common thing. And also we'll go for this 4 cells of the corner cells belongs to first column and second fourth column. Okay, that's what there is a different, there is a common term is what? D bar. Here is the D bar is there 0 0. Common term is what? D bar. It's a C is changing its state from C to C bar. That's what, don't consider this one. Then we'll write the simplified form as what? F of A, B, C and D is what? Equivalent to having that BD plus B bar, C bar plus B bar and D bar. This is the simplified form. How can we implement this with the Boolean gates? So Boolean logic gates means some basic logic gates. I will be taking this one as the B and D as the 2 inputs to the what here AND gate I am having because of the product form. Okay, because of the product form I will be having the AND gate here. Okay, next is what here? B bar, C bar. Okay, just to write B bar and C bar. Okay, there is also 2 inputs are there. Just to take this one as the B bar, C bar. Another input is what? B bar, D bar. Next is what? B bar and D bar. Take one more inputs are there. This is also one more AND gate only. Okay, then we'll go for the B bar, D and C bar. It becomes what? One OR gate here. One OR gate, you put one OR gate here. Okay, one OR gate here. Okay, this one becomes what? These two terms here. One more term here left here. I can draw the one more OR gate here because of the this plus. Okay, this nothing but the this is the what? F. Okay, this is the expression the my Boolean logic equation. The expression with the K-map I simplified with the K-map. Then I express this simplified Boolean expression with what? Basic logic gates. That's nothing but the AND gates and the 2 OR gates. 3 AND gates, 2 OR gates. Then I can write directly with this program, this simplified Boolean expression, and also even I can also write with the Boolean expression. I can now write with directly with the what? Different types of Verilog code as a structural or data flow model. While saying this structural or gate level modeling, while seeing the figure here, the simplified figure, I can write with the 3 AND gates, 2 OR gates, or else I can also write directly to the with the what another type of Verilog code writing. That's nothing but the what data flow model, or else I can use the behavioral model also while using this technique. Okay, we'll see how to write the program for this, and also we'll simplify. Before going to proceed, I have to simplify this with what? Truth table. I have to refer with the truth table. Let me see it how to draw the truth table here. This is what a truth table I have drawn here. I can get it the output as y. Here he has taken the y, but I have taken this one as the f here. Okay, this we can see it's what a truth table. How to verify this truth table? My given written Verilog code, how to write it, and we'll see next step. Start the computer. Okay, just to launch the my Xilinx 8.1 here. Double click on this, then click on OK. It will ask some pop-up windows. It will go some 2 windows. It will go. Don't take tension. Just to it will is asking that some tip of the day and all. It will not at all useful. This is small window, we can pop up window just to make it close while clicking on OK. Then go for the file. Okay, then start creating the project here. Just to go through what project file, new project. There you will find the project name also. You can write it. Project name can be anything here. Just I am writing the DDCO project name as the DDCO. Okay, DDCO project name. And also I am storing this one is what location, project location he has given mentioned, DDCO practice 1. I am taking this one as practice 77 project location. This one we should have to make sure of top level source type is what HDL, because we can have the so many different types here, but you should have to HDL means once hardware descriptive language. Okay, next we'll click on next. We should have to make sure of family as the Spartan 3 and also drivers as the XC350 as this one. Package is PQ208. We should have to make sure of this one. Okay, then the speed is -4 only. It was earlier 5 and all he has given, but you have to mention it and click on next here. But the synthesis tool is he has mentioned XAST, and also simulator is what ISC simulator. We should have to remember these things. Okay, next click on next, then click on next here. Okay, source type and all you don't take tension. Click on next, finish it. Okay, then we'll go for with what file, new project. Already we done with the file, new project and all. Then we'll start writing some code. New source Verilog model. We have to select Verilog model. So many models are here. Just to writing the what Verilog code here. So that's what we will writing. We'll be writing what kind of a K map. Okay, today we'll be discussing the K map here. So I'm writing the K map here. K map with the 4 variables. K map with the 4 variables. There should be underscore always. Okay, if it's underscore is not there, then it will not take in consideration. And also 4 variables. You can write 4 variables also. 4 variables. Then okay, then click on next. And also we can define the inputs and all, output and also, but not necessary to define. If you interested, you can also define here only. Okay, there's a possibility having the inputs also here. Better to have the there also you can write. Just you write if you are interested to write here A, B, C and D here. Okay, and also Y or F. Okay, you can take anything. F as my output here. F as my output here. Okay, just to change the F as the output here. Then keep on OK. Click on OK. Next, finish it. Okay, my Verilog code it has generated some Verilog code here. Okay, this is completely model K map variables. This is the A, B, C, D, and F as the inputs. These are the input A, B and C, and E as defined. Next step is what directly I can write my Verilog code. Okay, my Verilog code here. Either I can write with what a structural model or structural model or gate level modeling. Okay, same both are there. Or else I can write with the what behavioral model, or else I can also write with the data flow model. Just I am writing the we'll see. First time this was somewhat clumsy, more than 4 variables and else, so that I can use this variable code with the behavioral model only, because behavioral model can have the 2 variables. That's nothing but I should have to define the register. Okay, register is what somewhat which will be used for the expressing writing the having what output value register with having the output as the register. Y is F is what here my F is what my input variable, F is output, so that register F is there. Then always should be I have to use always keyword. I am using always at the rate, always at the rate. Okay, I use the always at the rate, and the in this always at the rate in between these two bases I will be defining the inputs. Okay, inputs are which are those? A, B, C, D, R. Okay, A, B, C, D, R. So I defined register is used for the writing what here output, and always within the always at the rate within this we can write the inputs here. We can define inputs here, so that I can write here. Next is what? Next is begin, because I am using what here the behavioral model, so that I will be using the begin keyword. Begin keyword, begin. Okay, begin here, begin I am using, so that that's nothing but the begin. Within this one begin, after the begin I have to write what? The end also, because end in between these two begin and end I have to write what? Some conditions. What the condition I am here having? This one as the boolean expression. Simplified boolean expression is what here? Something which is already we have seen the b bar, d bar, something is I got there, no? That one we can say it's what? F is equals to what? Boolean expression. That's nothing but the having the inputs as here the b bar, d bar. There we have seen the b bar, d bar. Sorry, b and d, bd. I got the simplified mean term for the first one is what? Bd I got. Bd are multiplication together. Then it is to be what? OR gate I have to use. For the OR gate purpose I will be using what? Straight line. Next is what here? And next term is what? One more straight line I need here. One more AND gate I will be preferring. And then put the semicolon here. Within this one we have to be writing here what? C bar and D. C bar and D. So for C bar purpose I will be using what? Tilde here. Tilde of what? C. Tilde of C. There's nothing but the C is tilde is nothing but the C bar and D and what? D and what? D and D. Then the I have to be write what? Next term, which is the simplified form, is what? Next term is what? B bar and D bar. For B bar purpose I will be using the tilde here. Okay, tilde here. B bar purpose I will be using the tilde here, and the what? And here, and I am present I am using here and purpose, and I am writing with the D here. D, okay, D here. That's nothing but the D. I am tilde of B. Tilde of D. Okay, tilde of D. This is the completes my Verilog code. Let's see how to we be using first, and then the check the save the program here. Just clicking on the save button here. My program is ready. So let me see whether the program is saved properly or not. Okay, let's see. Next I'll be clicking on this one as the then the design utilities. That's nothing but the synthesis will be seen. Check syntax. I am going to check syntax. Double click on the check syntax. Then the syntax is written completely successful. Okay, successful. Then the I'll be seeing what? View RTL schematics. Click on the view RTL schematic. I got the 4 inputs and the 1 output is there. Double clicking on that, we'll get the 4 inputs. 4 inputs are the B, C, D, and the F is the output. Is here. What here? As already we have simplified this Boolean expression with the 3 AND gates are there. B, D, and this B and D, and this is what? D and C, and this is what? B bar and C bar. Something is it was there. That's nothing but the AND gates, 3 AND gates, 2 OR gates I used there, but also I can use the 3 input OR gates. I can also use the 3 OR input OR gates. He has used this is the schematic diagram, RTL schematic diagram. Okay, RTL schematic diagram. Next we'll see for the next I'll be writing the test bench here. New source on that, and click on the test bench where Verilog test picture. just you write the test itself, only test, okay, only test picture or test you can write it, okay. Then click on next, then for next, okay. It will automatically generate some test bench here, for initial setup for the 00. But is there we are using the 4 variables, means 16 combinations there we are using. Just you copy paste for the 8 times, will get the 16 times. First combination, the two table there we are using the a equals to 0, b equals to 0 0 0. Next combination 0 0 0 1. Next combination is what, 0 1 0 0 1 0. Next combination 0 0 1 1. Next combination is what, 0 1 0 0. Next combination is what, 0 1 0 1. Next combination is what, 0 1 1 0. Next combination is what, 0 1 1 1 1. Like this will be having up to 16 combinations. I will be having. Copy paste and make it changes in this. Just change the K map with the test bench here. 0 0 we already have the first initially 0 0. Next we will have the 0 0 1, okay. Next we will change the D variables as the having the 1 year. Next we will be having the 0 0 1 0, yes sir, 0 0 1 0, yes na, 0 0 1 0. Next we will be having the 0 0 1 1, yes sir, 0 0 1 1. So that I will be having the 0 0 1 1 here. 0 0 1 here. Next here I am having the 0 0 1 1 here. Next combination is what, 0 0 1 0, 0 0 1 1 1 0 0. Next combination is what, 0 1 1 0 1, okay. Like this I have to be put each and every combinations here for 16 combinations here, so that I will be having here. This one is what, 1, this one is what, 1 also, 1 1 0. Next is what, 0 1 1. Next is what, 1 only. Next is what, fourth option 8. This one is what, 1 only, because it's a 1 0 0. Next is what, 1 0 0 1 0 0 1, okay, 1 0 0 1. Next is what, 1 0 1 0 1 0, okay, 1 0 1 0. Next I will be using what, 1 0 1 0 1 1. Next is what, I am having here what, 1 only, so that this one is what, 1 1 1 1 0. This one is what, 1 1 1 1 1 1. This is what, 0 1 1. This is combination having the inputs as what, 1 1 1, and also this is what, 1 only, and 0 here. This is what, I need one more option here, so that control paste. I need one more combinations here, so that all are ones, okay, all are ones only. 1, all are ones, 1, all are ones, 1, all are ones, means what, 1, because it's 8 combination. Just to make the save button, click on the save button here, click on the save button here, or else you can use the Control S also, okay. This is what I saved here. My next is what I have to go with what, here the program is here, KMap is here, KMap program is here. Just to click on KMap technique here, KMap program. Thereafter you will get the check syntax and all. There will be check, then the will select synthesis and behavioral simulation. Just I'm selecting the behavioral simulation here. Okay, then the design utilities are there, will not get. So just to click on this, then only will get the Xilinx ISA simulator. Xilinx ISA simulator. Then the check syntax is not necessary. Simulate behavioral model. Okay, just to click on simulate behavioral model. I have the 16 combinations here. First it is the last one is the 1101 combination, the 1010 combination, 8th one result he has given. Output is what? 1 only. That's nothing but here we have seen. Let's see how to get the result here. Just to click on, just it's what? 0 0, all are 0. Then the output F is what? Also 0 he has given. Next is what here? All 3 are zeros. Okay, A is 0 and B is 0, C is 0, D is 1. Then the output of F is what? If all are 0, then the output is what? 1. If all 3 zeros, 0, A is 0, B is 0 and C is 0, D is 1, then the output is what? 1 only. We have already seen this one is we can check this one with that truth table. Once we let's see it's all are 0. A is 0, B is 0 and C is 0, D is 0. Output is what? 1. Okay, now we can see here A is 0, B is 0, D is 0, A is 0, B is 0, C is 0, D is 0, F is what? 1. The output is what? Similarly here also A is 0, B is 0, C is 0, D is 0, then output is 1. Similarly you can verify the complete waveforms here, each and every waveforms with the help of this truth table. This is truth table, so that my whatever the I explained got the expression. This is the variable Verilog code with the behavioral model I have written, and the Verilog code. This completely matched to my matching here means what? Verifying the each and every programming techniques will completely matching, okay, with my waveforms and the truth table here. Truth table, that's the nothing but the I have written whatever written the Verilog code for the 4 variables K map, which is right. Okay, so this is the end of the programming. This is nothing but I have verified the 4 variables K map with the help of what? K map techniques, and the simplified the Boolean expression, and also written with the basic logic gates. That's the basic logics are gates are simplified Boolean logic. That one is written with what? That one is written within the Verilog code. Okay, Verilog code. You can say it's a Verilog code here. You can say it's Verilog code, and also I have written the some K map with the test. This is right. Okay, then the I have written with the some this completely this complete okay, this complete this code with the help of whatever this one in the K map simplification we got the truth table. This one we written with here the some coding. Okay, this is generated. We can see its name as the test code. That's nothing but the Verilog code will be using for the verification of my result. After the simplification I got the result here. What? Simulation. This is completely simulated simulation waves. This is completely verified my truth table with the waveforms. The right is things I got here, so that this is verified my 4 variables K map with the design techniques, and also Verilog code also. Okay, thank you for watching videos, and please keep on watching my videos. I will be giving the good videos for you guys, students. All the best, students. Okay, please subscribe my YouTube channel and get the updated new videos here. You can get write the of your own coding here. This I explain very easily. Okay, these are the inputs, these are the outputs, these are the inputs, this is the output register. Here I am using always keyword. I means what? It's a behavioral model, begin, end. Okay, this is in the between I have got simplified Boolean expression I have written in the Boolean variables, Boolean the Verilog code. That's nothing but I executed, and I got the test code also written, and also simulation result I got the completely is right. Okay, this is the way how to solve the right k-map Verilog code for the k-map without the don't cares. Okay, next video we'll see the with the don't cares, how to write a solve the k-map with the and with the don't cares, and also how to write a Verilog code for that one, how to simulate, and that one we'll see next video. Thank you for watching video, and please keep on watching my videos. Please subscribe my YouTube channel. Thank you.